Hello guys, my name is Dimitris and this is AI in Space Tech. And if you don't know about our channel, we always discuss topics related with AI, machine learning and remote sensing. And I've actually made this channel to put together all these fields because in the field of remote sensing where I'm currently working, I believe there's a huge gap between what's happening in academia and what's happening in the industry, in the companies out there. So this is an educational channel and it tries to minimize the gap by talking about the amazing events, the amazing research that is happening out there now, and bring it to the industry, bring it to all of you who want to educate yourself. So every episode goes as follows. We have two sections, the news section and the knowledge section. And I will start now with the knowledge section. And unfortunately, even though I tried hard to find some news from the remote sensing community, I wasn't able to do so. The reason for this, it's mainly because there's not any good websites that at least I know of that they talk frequently about updates and news coming from the remote sensing community. So if you know any website out there, guys, that contains this kind of up-to-date information, please let me know in the description below the video. Anyhow, I brought some news from the AI field where we always see tremendous breakthroughs, and there's always news as there's so much research and so much discussion going on. And I think that would be interesting for everyone out there. So let's get started. So the first topic I want to talk comes from the official Nvidia website and actually from their blog. And they're talking about the new supercomputer called Summit, where you can see it actually down here. So let's read the article. Reaching the Summit, accelerated computing powering world's fastest supercomputer. And this massive machine powered by 27,648 of our Volta Tensor Core GPUs can perform more than 3 exaopt or 3 billion calculation per second. That's more than 100 times faster than Titan, previously the fastest US supercomputer completed just 5 years ago. And 95% of that computing power comes from GPUs. So this is, I believe, great news. The amount of GPUs, almost 28,000. It's a huge number considering the fact that they're using the new Volta architecture for these GPUs. And what I found even more amazing is that this supercomputer is 100 times faster than their previously constructed fastest US supercomputer, which was just completed 5 years ago. So in 5 years they made 100 times faster supercomputer. I mean, that's tremendous power, and that's amazing. So instead of 1 GPU per node, Summit has 6 Tensor Core GPUs, delivering 10x Titan simulation performance. So, I mean, how they actually do that is because they use per node, not just 1, but 6 GPUs. And of course, these GPUs are also more powerful, and that delivers 10 times the power that their best supercomputer had before. Summit is a new breed of computer, Huang said. Summit is the world's largest AI supercomputer, a machine that learns. Its software will write software, amazing software that no human can write. And of course, Huang here refers to the CEO of Nvidia, and I think he is like overestimating a little bit here the facts. But I mean, we don't have currently any computer that runs software better than humans, but who knows, maybe in the future. Nevertheless, there's still a very active area of research of actually using previously written code to write new code. And I think this is a very, very interesting area of research, but I'm not sure if we can still perform these kind of big statements referred here. So what the Summit supercomputer will be used for, there are three main purposes. So cancer research, the DOE and National Cancer Institute are working on a program called Cancer Distributed Learning Environment. Their aim is to develop tools that can automatically extract, analyze, and sort health data to reveal previously hidden relationships between disease factors such as genes, biological markers, and the environment. So cancer research, an amazing area of research where we may see great breakthroughs with these big computers. Another one is fusion energy, and actually it refers to nuclear fusion. So fusion, the energy source powering the sun, has long been touted for its promise of clean, abundant energy. Summit will be able to model a fusion reactor and its magnetical confined plasma, hastening commercial development. Amazing. I hope they will achieve something. I hope we will see some nuclear fusion energy out there, because we definitely need it as a society and will benefit everyone. And last but not least, they will use it for disease and addiction. And the article says researchers will use AI to identify patterns in the function and evolution of human proteins and cellular systems. These patterns can help us better understand Alzheimer's, heart disease, or addictions, and inform drug discovery process. So amazing news, amazing use of these superpower computer, and I think we're gonna see some amazing breakthroughs with these kind of systems. And here you can see picture of the Nvidia Tesla V100 processor with the Volt architecture. I think it's an amazing piece of hardware, and of course when you see it integrated in these big computers here, I think the humanity can only has huge benefits out of it. So saying that, let's see what will they achieve. Okay, so moving on, some news from the EARCSC, the European Association of Remote Sensing Companies. So what the EARSC blog actually discusses here is the budget of the European Union after the time of 2020. So what they say here is that the European Council has published its proposed budget for the next multi-annual financial framework perspective 2021 to 2028, which includes an allocation for space of about 16 billion euros. This will provide continuity for the two European Council flagships, namely Galileo and Copernicus. And of course the article says a few more information, but what is important is that the association called upon the decision makers to ensure an adequate proportion of around 25% of the program budget is dedicated to the services, to user uptake, and to the development and exploitation of the data being generated. And what I want to say here is, of course, I think it's very important the European Union allocates such a budget for future research and future missions, Copernicus, Galileo, and so on and so forth. But nevertheless, I think the money is not so much. And why? Because of course this is for a multi-year program from 2021 to 2028. So these are like 7 years there. And of course we're talking about two very big projects, Galileo and Copernicus. Galileo, if you don't know, it's the European GPS, and of course this doesn't have to do more or less anything with remote sensing. And the Copernicus, even though it's an amazing program and creates a huge amount of data that currently are considered the best source of information out there, the problem with them is that a big part of this budget is going to be consumed for actually the storage of the data, the update of the systems, the ensuring of the downlinks and so on. So I'm wondering what eventually will be the number of millions or billions that will be available for research on the information extraction side, which is what we're dealing here with. And in computer vision, we have seen amazing breakthroughs by actually investing in the algorithmic part, in the ways you can extract the information. But here, what we see mainly is that this money will probably go to the continuation of the programs, the centers where they monitor the satellite, the downlinks, the storage, and so on and so forth. And 16 billion, okay, is not a small number, but considering how big is the economy of the European Union, including countries such as Germany, France, and Italy, I don't think this is a big number. US and Japan and China, or even India, they're investing a lot more money probably for satellite technology out there. But let's see. I hope I'm wrong, and I hope we will have better news in the future. So I want to finish this news section here with some nice imagery, and the imagery will be from the island of Tenerife. And if you don't know, the island of Tenerife is actually belongs to Spain, but is located very close to Africa. So here is Morocco, and here is the constellation of the Canary Islands. And what you can see here in Google Maps is that in the middle of Tenerife, there's a big mountain. And if you don't know about this mountain, the mountain is called Teide, I think that's how it's pronounced, and it's huge. And when I'm saying it's huge, it's so huge that actually Spain, which is a very big country, doesn't have another such high mountain. So its highest mountain actually is on an island in Canaria, and specifically on Tenerife. So Teide Peak can be seen here. This is an image taken a couple of years back, and the image was actually taken by an astronaut from the International Space Station. So as the International Space Station was passing by the Atlantic Ocean, this guy here, Tim Peake, he took this image, and I believe it's amazing. You can see almost the whole extent of the island between the clouds here, and in the middle the huge volcano, because it's not a mountain, it's actually a volcano, which is actually rises up to 3,718 meters, I guess, or something like that. But anyway, it's 3,700 meters at least. It's a little bit higher than that, and yeah, it's an amazing image. And this shows to me how important is remote sensing, how much information we can actually see in this image, and we can see information regarding our planet, which is the most precious thing we have. So that was it, guys, for the news section, and now we'll move on in another video into the knowledge section. And this time for the knowledge section, I will present a paper from the community of computer vision, and this paper will deal with breakthrough architecture that was proposed back in 2015 regarding convolutional neural networks and how you can actually semantically segment images better. So they proposed a better architecture based on what was back then the state of the art. Unfortunately, you guys didn't provide me any feedback regarding what kind of paper you would like to see this time, so I had to choose this paper myself. I hope you will enjoy it, and if you're interested, stick with us in the next video regarding the knowledge section. So that's for now, guys. Bye bye.